If you graph the equation y equals x squared, you get a basic parabola. If you revolve the parabola around the y-axis, you get a paraboloid. Imagine if you were to drop a ball into the paraboloid. As long as it was sufficiently small, the ball could easily touch the bottom. But if you made the ball larger, there would eventually be a point where it would become too big to touch the bottom. Find the largest possible radius of a sphere that could touch the bottom of the paraboloid. First of all, we only need to think of this in 2 dimensions, with a parabola and a circle. In its simplest form, this problem is asking us to find the radius of curvature when x equals 0. A quick way to do that would be to use the radius of curvature formula, but I'd like to show you what I think is a more intuitive solution that doesn't require any calculus. Let's start with the equation of a circle, where hk is the center. If we call the radius of this circle r, that would mean its center is at 0r. And in this case, we know the circle will always be touching the parabola at the origin, 0, 0. In fact, that must be the one and only point where they intersect. If there were any other points of intersection, then the ball would already be too big to touch the bottom. Therefore, if we set these 2 equations equal to each other, or plug one into the other, we should be able to find out where they intersect and compare that information against what we already know. Y is equal to x squared, so we can plug that into the other equation. And then if we square y minus r by foiling, we get this. There's an r squared on each side that we can cancel out, and then we can factor a y out of every term. Now set each factor equal to 0, and solve the equation on the right to get 2r minus 1. So these are the possible points of intersection between the circle and the parabola. It should be of no surprise that we get 0 as a solution, since we forced that condition. But any other solutions besides 0 will mean that the circle is too big. So the only acceptable solution to this other equation will be one that makes 0. Solve for r, and this is the largest possible radius of a sphere that can touch the bottom of a basic paraboloid. I hope you enjoyed this video and that you learned something new. If so, please take a second to like and subscribe. Thank you all for watching and have a pleasant day.
Shh.